Hi, my name is Carlos Avila, and this is my review of the dynamic multiphase flow simulator ALFAsim.
Welcome to the review of the ALFAsim multiphase flow simulator. ALFAsim is a 1D dynamic multiphase flow simulator developed by ESSS. The version that I tested was version 1.8.0, although there is a new version that is coming up in the next few weeks. Let's take a tour of some of the capabilities that ALFAsim can do. Welcome to the overview of the ALFAsim simulator. First, let's start showing you this simple case that I built with a mass node and a pressure node that I dragged from the left. And then I proceeded to connect. This is done fairly easily in ALFAsim. You just have to click then on the connection between the source and the pressure boundary. Then you can modify the profile, clicking on this button. Then you can specify the different lengths and elevations and set up your case. In this case, it's a very simple, slightly inclined downward flow line, and then followed by a straight up riser, which I've done on purpose to simulate a severe slugging case. I'm going to show you now, for this particular case, some typical results. To see results, you have to click on this button up here to look at trend results. Let's click on that. And then you have your typical variables that you would observe in a multiphase flow simulation. In this case, let's select the pressure. So we have the pressure in time at multiple locations along the flow line. First at the entrance, this is at the bottom of the riser, somewhere along the line, and at the top of the riser. So we have these simulations in time. And perhaps, let's suppose that you want to look at zooming into a particular time period during the simulation that you want to look into more into detail. Let's suppose that time period goes between 5 and 10 hours, so you can specify that. Let's specify a step of 1 hour, just to make it easier to read. Then you can see here now we have these pressure fluctuations that we were observing before, just narrow to this particular period of time. We can select or unselect if you want to see all the information at the same time. You just click in the legend and each of the series, and then you just add or remove from the plot. So here I just left the pressures at the bottom and the top of the riser. We can see this cyclic behavior in pressure that is typical of the severe slugging case. So in this case, the simulation, it's making sense with what we were expecting for this kind of geometry and the particular flow rates that I picked. We can add other variables, such as holdup, that is also very useful in multiphase flow. Here we can see the behavior of the pressure and the holdup at the same time. So the pressure in this red series, and in gray, we have the holdup at different locations along the riser. Here we have these ones that are flat at the bottom. They're probably at the entrance of the flow line, where these ones that go all the way, fluctuate between 0 and 100% holdup are probably the ones that are close to the bottom and the top of the riser, corresponding to the phenomena of severe slugging. Now, if we close this, now let's open a profile plot. If we click on this button, we can open a window that generates the profile plots. Here, typically, we would like to see the elevation. So when we see the results, we can see as a reference our flow line elevation profile. And we can see different features. For instance, the holdup. We're looking at a profile of the holdup in this flow line, in particular for the last second of the simulation. And if you click on this button over here, we can actually see an animation of the different profiles captured during the simulation, depending, of course, on the rate of which you are capturing those profiles. But you can see that it's reflecting, what is expected change with a large liquid holdup, the area near the bottom of the riser and the immediate area upstream of that low spot where the liquid tends to accumulate. We can add other variables that help to visualize the problem. In this case, let's add the oil volumetric flow rate. And similarly, so we have now here the oil volumetric flow rate along the flow line in black. And we can repeat that animation so you can see both the holdup and the liquid flow rate changing in time. And if you pay attention, you will see that close to the riser, you will see some spikes in that black series that goes up high to, values close to 80,000 barrels per day, showing how, the fluctuations in flow rate can be expected in severe slugging. Another useful thing to know is that you can right-click on the figure and export this information by either selecting the individual curves. So you select which information you want to export and create text files that you can later use. So let's close this, and now let's look at another case that I created to evaluate the capabilities that ALFAsim has. I'm going to open a case where I added one of the modules that is here, that is the separator module. As you can see, before I forget, there are multiple modules that you can use in ALFAsim, the well module and so on, valve. But for the time being, I only spend time just using the basic flow line models for multiphase flow. And in this case, I just wanted to test the separator model to see what were the capabilities. So as I did before, just drag that separator into my model and then create this multiphase flow model. In this case, we have a multiphase flow source coming into the separator, and then the separator is going to provide gas, close to gas, a single phase gas in a line over here, and a close to single phase liquid line over here, going to two separate pressure boundaries. If we click on the separator module, we can see that we have a separator with the associated PVT model. And I just specify a generic horizontal separator just for the purposes of looking at what would be the outcome of the integrated model. Then here you specify, the way you specify the flow lines that are going to connect into the separator is that you specify the height with respect to the bottom of the separator of where the gas and that liquid outlet are going to be located. So in this case, the 6-inch line is at the bottom, which would correspond to the liquid line, and the 8-inch line is at the top of that separator, which would correspond to the gas. Then if we quickly go over here, you can click on that line. You can see the profile of these lines are a typical platform-to-platform case. And you can look at the profile of those results. Again, look at the elevation profile. Look at the holdup profile and pressure profile. And then basically what we're looking at here is the gas line, right? So this is a very low holdup. And this is the profile that you would expect for that gas line with that particular separator there. Of course, ALFAsim in the current version has a ideal separation efficiency. It currently doesn't have a capability to modify that separation efficiency, but that's something that they're considering to incorporate in the future. We could also look at the other liquid line and similarly create a profile for the same variable. So we look at the elevation, the holdup. Now the holdup here, you can see that it's much higher. It's close to 0.9 at the beginning of the flow line, and as it evolves along the line, it reduces as, I guess, some gas comes out of solution. And we have a pressure profile for that too. We could also create an animation here just to look at how the simulation evolved from the initial conditions to the final states in the simulation. You can see that eventually there is some minor fluctuations that might be some combination of hydrodynamics logs or other changes. So anyway, I already explained previously that you could export data from the results directly from the plots by right-clicking and doing the export and curves to select each of these time series. But as you create more complex simulations and you start developing models where you're trying to run multiple cases, a parametric study, if you will have larger and larger amounts of information to manage. So for that, there's a button over here that's called Export Output to Excel. And that button basically does a data dump from all your results of the most typical, variables that you would need from a multi-phase flow simulation. So this will create multiple Excel files with all that information, such as holdup, flow rates, pressures, for each of the locations that you were saving data. So it will create actually a variety of profile and trend Excel files that you can use later on to do your post-processing. That will help you save some clicks. And if you're like me, I'm always looking for opportunities to reduce the number of clicks and reduce my chances of getting a repetitive stress injury. So this is my quick tour of the ALFAsim simulator. I hope this was helpful for you. So conclusions, ALFAsim is a 1D dynamic multi-phase flow simulator that provides results in a prompt manner. That's something that I notice in ALFAsim, is that when I run my simulations, they run fairly fast from the severe slugging cases to the ones with separation. So this encouraged me to go there and run faster, more complex cases, and try things like large parametric studies, which then the speed of the ALFAsim engine facilitated. Anyway, you can find more information in their website. And thank you very much for your attention.
Thanks for watching. I hope you enjoyed this video, and I'll see you next time when I discuss another topic on multi-phase flow. Thank you.